AP Calculus, AB, Rolle's theorem. Rolle's theorem guarantees a value of C on the interval AB such that f prime of C equals 0. In other words, the first derivative has to equal 0 at some point on this interval, as long as the following three things are true. 1, the function is continuous on the closed interval. 2, the function's differentiable on the open interval. And 3, the endpoints are the same height. That is Rolle's theorem. Let me try to give you a picture to represent this. So if we have a point here and a point here, and let's say this is A7 and this is B7. So they're the same height. Rolle's theorem is saying no matter how I draw a curve from A to B, as long as it's continuous and it's differentiable, there has to be at least one place where the function's derivative is equal to 0. So let me just give you some examples. Let's say I do this. Well, that's a horizontal line. Its slope is 0 every place. Let's say that you have a maximum and then a minimum. Well, there's two places. First derivative is equal to 0 is equal to 0. Let's say you think, okay, what if I do this? So not equal to 0, not equal to 0. That's true, but it's not differentiable at all places, so that cannot apply. It is impossible to draw any type of curve that is continuous, differentiable, and the endpoints have the same height, and there not to be at least one place where f prime is equal to 0. That's what Rolle's theorem is telling us. Consider the function f of x presented on the previous page. Let's see, I should probably grab, that's this fellow right here. And you can see the graph here as well. Does Rolle's theorem apply on the following intervals from 2 to 14? I'll tell you what, let's just do this even easier. Let's just grab this. Let's look at it. So from 2 to 14, so that would be from here to here. Does Rolle's theorem apply? Well, for one, is the function continuous? We would say yes, f is continuous on the closed interval from 2 to 14. Check. B, is the function differentiable? That's a nice gradual curve. So we would say f is differentiable on the open interval from 2 to 14. So we don't care about the endpoints for that. And then C, are the endpoints, do they have the same height? Does f of 2 equal f of 14? It sure does, because they're both 5. Therefore, a conclusion we can make Rolle's theorem guarantees a value of C on the open interval 2 to 14 such that f prime of C is equal to 0. And if you want to know the truth about it, that's happening here at 8. Doesn't ask for this, but I'm just going to tell you. The guaranteed value of C is 8. We would have a horizontal tangent line there. How about on the interval from 2 to 10? here's 2, and here's 10. Now, it's true that it's continuous, and it's true it's differentiable. We don't need to mention that because this isn't going to work. The important thing is here that f of 2 does not equal f of 10. If one of those things aren't true, then we don't have to list the things that are. We just worry about the thing that isn't true. Since f of 2 doesn't equal f of 10, Rolle's theorem does not guarantee. I'm going to cheat here. Therefore, Rolle's theorem does not apply. That's good enough. Since it doesn't apply, it means there's no guarantee. I mean, it could still happen, but there's no guarantee that there is a derivative here that's equal to 0. All right, let's check out some examples here without graphs. For each of the functions below, determine whether Rolle's theorem is applicable or not. Then apply the theorem to find the value of c that exists. All right, so first of all, is this function continuous? It sure is. This is a polynomial function. All polynomials are continuous. So g of x is continuous. And we say on the closed interval from -3 to 0. Is it differentiable? Well, if you know what a polynomial function looks like, a polynomial has nice continuous curves. All polynomial functions are differentiable. And that is from -3 to 0, the open interval. And then the next thing, like those are pretty easy to figure out if you know what the function looks like, and we should know what a polynomial looks like. What does g of 3 and g of 0 equal? Do they equal each other? Well, let's see. If we put a 0 into this, this is going to be minus 0 squared times 9. This is going to be 0. Put -3 in, -3 squared, that would be 81. 9 times -3 squared, also 81. Those are both going to be 0. So we know from this that Rolle's theorem applies. And since it applies, let's find the value that we're looking for. Now you might get multiple values of c. That's cool, but we need the one that's between -3 and 0. So g prime of x is going to equal 18x minus 4x cubed. Just use the power rule twice. We need to know for what value of c would this be equal to 0. So I'm going to set this equal to 0, and I'm going to replace my x values with c. The direction said for what value of c. That's why I changed those to c's. If you chose not to change those to c's, I don't know if they'd butcher you on the AP Calculus test, but at the very end, I think you'd need to say what c is equal to instead of x is equal to. We've got a GCF here of 2c, leaving us with a 9er minus 2c squared. Set each of these factors equal to 0. And we end up with if we square root the left side here, square root 9, you're going to get 3. 2 is irrational. All right, so it looks like we got 3 possible answers. Is 0 on the interior of this domain? It is not. So we could say 0, I don't know if I've ever shown you this before, this means is an element of. If I put a cross out through it, we're saying is not an element of -3, 0. How about positive 3 over 2? That doesn't fit in this interval either. So positive 3 over the square root of 2 is also not an element of negative 3, 0. So our answer is the only one that did work, which is negative 3 over the square root of 2. That's what C is equal to, because this does fit into the interval of negative 3 to 0. It has to be between the endpoints. It can't be an endpoint. Let's check out another. All right, so it's okay for our function not to be continuous as long as it's continuous on this interval. So let's see, is this continuous? The only place this is discontinuous is when x is negative 2. Bummer. So we could say that g of negative 2 is undefined. Therefore, g of x is not continuous. On the closed interval negative 4 to 1, negative style. Therefore, Rolle's theorem does not apply. If Rolle's theorem does not apply, that means there's no guarantee there's going to be a place on this function between these x values where f prime is equal to 0. It could happen. It may happen, but there's no guarantee. That concludes the video of Rolle's theorem. In the next video, we're going to discuss the mean value theorem.